Alright, hey guys, I'm going to be showing some of the intuition behind finding the average using integration, being the average of some function over some value of its argument between a and b. Alright, so I'm going to start off with the series representation using sigma notation. So this just implies that each whole number value of t is being subbed into this formula, and then we're adding up all the resulting values. So this is what this integral can be represented as in discrete notation. So we have a lower limit of t equals 0, so you plug in t equals 0, you've got f of a, lower limit at which you have the integral. And you're multiplying that by delta x, so you're also taking the limit as delta x approaches 0, so each time you see delta x, this is a value that's equivalent to the differential of x. So you have a lower limit of t equals 0, an upper limit of b minus a over delta x. So that is the value of t. You need to get a plus t times delta x to be equivalent to b. So that's also just the number of values in which you're going to be adding up in this series. Alright, so if you sub in each part where you see delta x for dx, divide each side by dx, because the dx also has the property of first order homogeneity, just like any constant involved in integration and differentiation, which just means that you can, if you have the integral or derivative of some constant, you can just take the derivative or the integral with the constant factored out of the expression, and then multiply that by the original constant that was in the expression. And those two values would be equivalent. So you divide each side by dx, you get the integral from a to b of f of x with no dx is equal to this sum. So you can notice that this is going to be a value that is infinite. There's no dx, so there's no that you're multiplying it by. And so this is approaching infinity, and basically it's adding up a bunch of values of the function, an infinite number of values of the function, and that's just an infinite value, I mean. So this value up at the top, b minus a over dx, that is equivalent to n, which is the number of elements being added in the sum. You could do some algebra, you get n times dx over b minus a is equal to 1. So now you're going to use the definition of an average with the sum, or the equation that relates those things. So the average is equal to the sum divided by the number of elements that you're adding in the sum. So you can reorganize, you get n equals the sum divided by the average of that sum. So if the sum that you're considering is the integral from a to b of f of x, then you can use this formula, subbing n is equal to, in the integral from a to b of x, divided by its average, which I'll represent with f of x with a bar over top of it. So this is what you get. The integral from a to b of f of x over the average multiplied by dx over b minus a is equal to 1. So you can do some more algebra. What you get is you multiply each side by the average of f of x, and you get the integral from a to b of f of x dx over b minus a. It's equal to the average of f of x. Isn't that cool? Alright, thanks for watching.